Hi, the purpose of this video is to help you out learning how to do standard deviation, variance, skew, kurtosis in SPSS, and it should prove useful for your assignment this week. So here's GSS, and here you have your Analyze tab. That's the #1 tab that you're going to use in SPSS, other than opening file, saving files, which you do here. So we're in the Analyze tab, and we're going back actually to descriptive statistics where we've been before, and we're coming down here to descriptives. And this is because, as I've mentioned, standard deviation, skewness, kurtosis, these things really are descriptive statistics. It's getting to the verge where we can use them to do some inference, but we'll talk about that a little bit more in coming lessons. So we click on descriptives right here, and then let's choose email hour. I have it in there already, but if you're on this view where you have the full variable names, you might want to right click with your mouse and then switch to whichever one of these is not highlighted, but really it's display variable names. We want kind of these short names. Then you can just start typing email and it'll come up. So email hours, this is the number of hours people spend on their email each week. You might think it would be a lot. But what we're going to do is go over here to options. So once you have email hours in here, click on options right here. And we just check stuff off. So we want the mean, standard deviation, variance, skewness, and kurtosis. That's it. You can put them in the max if you want, but really you'll need check the mean, standard deviation, variance, skewness, kurtosis. And I'm not going to do min and max on here. It's kind of informational, but I don't want to clutter up what I'm going to show you here in a second. So then we hit continue down here at the bottom of this window. And we're going to click something else here, which is save standardized values as variables. So what this does is a really useful feature in SPSS. It's going to create a new variable called Z email hours, and it's exactly what it sounds like. It's going to give you the Z scores of every single person, of every single observation within this email hours variable. Super cool option here. You can click the Save Standardized Values as Variables. I've used it tons of times in pretty complex analyses. So check Save Standardized Variables, then we hit OK right here. So go ahead and click that. And up it comes. And we have, I'm going to go here to not give any spoilers. Here we have N is what? Number of observations. In our variable email hours, we have 1,471, so you need to know that. Mean is 6.27. You basically need to know that, but it's not the most important thing here we're going to do for the assignment. Standard deviation is 11.335. And if you square 11.335, you will be surprised, or hopefully not surprised, to realize that you will get 128.492. And why is that? Because variance is standard deviation squared. Variance is simply standard deviation squared. Variance is standard deviation squared. And standard deviation is, therefore, the square root of variance. So you see exactly what you would expect here. And if you look at your data set, you're probably happy that you don't have to go through every single one of these thousands and thousands and thousands of observations. 2,538. In our case, 1,471 people answered this question. And if you do your xi column and your xi minus the mean, the difference squared, the sum of the squared differences, divide by n minus 1, you would be there a very long time with 1,471 observations. So we're very excited about SPSS and very happy to have SPSS in our lives, because just with a few clicks of a button, like you saw, you have this information. Now, what else do we care about? Skewness, 4.79, and kurtosis, 37.765. Now here's the key. This is what you need to be able to do on the assignment. You need to be able to take this and tell what the graph is going to look like. So what's the graph going to look like here if we did a histogram? What is the distribution going to look like? Well, the mean's going to be at 6.27, but we have a decent amount of skew going on here. 4.7 is pretty high. And crazy kurtosis. So anything above 0 is high positive skew. Anything below 0, well, it's not necessarily high, but the higher above 0 you are, the more you have positive skew. And the farther below 0 you are, the more negative, the more you have negative skew. For kurtosis, when you're higher than 3, that's considered to be peaked. And when you're lower than 3, it's considered to be flat. So the more you're above 3, the more kurtosis you have. This is a lot of kurtosis. You don't see this much kurtosis every day. So this is a big deal. So we should see a histogram that's kind of centered around 6, but tails off to the right, the positive direction. Has a long tail off to the right and has a huge peak there on the left side because of that huge kurtosis. And let's have a look at it. And we are stats masters. By looking at the mean, skewness, kurtosis, we can tell all about the distribution. And that's what you need to be able to do. And one more thing, where is our z variable that we created? We click that checkbox that says Save Standardized Scores. Standardized scores mean give me z-scores for each observation. So it creates the new variable clear at the end. So grab this slider right here. Okay, you're going to grab this slider. We're going to head clear over to the other end. So just drag this all the way over. And there is z email hours. So what you need to be able to do is realize that this observation, which corresponds to the email hours variable over here, which we're not going to dig it out because it is clear over here somewhere. But you need to realize that this corresponds to an observation, and you should be able to use the z-score and, wait for it, this standard deviation to tell me what the value will be of observation number 4. This is observation number 4. So even here on the z-score, you should be able to convert this, given that you know the mean of 6.27 and the standard deviation of 11.335. You should be able to convert this by multiplying 1.6. Here's a big clue for you. In fact, it's not even a clue. I'm going to tell you how to do it. Multiply 1.65 by the standard deviation and add it to the mean, just like we did all last week in your modules. I hope this video helps you with your assignment this week, and I look forward to learning more about statistics with you throughout this week and throughout the semester.